Ice cores allow us to look at what was in the atmosphere hundreds and even thousands of years ago. This can tell us what the climate was like then. So, Alberta during the last ice age. So, following the Pleistocene ice age, a great period of warming and melting occurred. This opened up most of North America for inhabitation by people. And currently, the oldest archaeological evidence of humans living in North America is from about 16,000 years ago. And people would still have traveled down the coast or traveled down the ice free corridor in the middle of North America. Now, if we're still using scientific definitions, yes, we're still living in an ice age. An ice age is defined as a period when ice sheets cover parts of the northern and southern hemisphere. So, if we look at the North Pole and the South Pole, we still have ice sheets. Now, glaciations are periods when continental ice sheets cover large regions of North America and Northern Europe, and people commonly refer to this as an ice age, when most of the continent is covered in a sheet of ice. So we have a lot of evidence that plants and animals we find on our planet today were not the same as those found millions of years ago. And one of these is from the fossil record. Also, a record of changing atmospheric, water, and climate conditions, and the continual discovery of new species. So there's the ongoing evolution of life forms, which we'll talk about later on in the course. So, a variety of evidence exists to just demonstrate that the climate of Earth has varied throughout its history. And this change continues today, and it's referred to as climate change and or global warming. So, some of the evidence that we use depends on humans, so it only describes the last few thousand years. So, when we look at things like weather records and crops that were grown. But some evidence allows us to look back at the Earth's conditions prior to humans arriving, so we can look back much farther. Two general types of evidence are anecdotal evidence, which is based on stories people tell, and this is a short personal story or an individual experience. And it's most often qualitative in nature. So if you even listen to your grandparents, they'll tell you it used to be so much colder when I was little, but they can't exactly tell you all the time how cold it was, what was the hottest temperature they experienced when they were your age. Instrumental evidence includes any evidence that comes as a result of measurement. So this would require special equipment like thermometers, ice core samplers, atmospheric carbon dioxide measurement tools. And this is quantitative in nature. So it can tell us exactly what the temperature could have been, what was the carbon dioxide in the atmosphere, and what was the depth of the ocean. So when we're trying to measure something, there are two different approaches that we can take. One is to measure it directly. Like if we want to measure how far it is to Calgary, we'd simply measure the distance. Want to know how hot it is? We can measure the temperature. The other one is to measure some other factor and then use it to make conclusions or an inference. So we can calculate the distance based on the speed of travel and how long it took. So to get from Edmonton to Calgary, it's about 3.5 hours. So depending on how fast you're driving, you can calculate how long it takes or how far away it is. So when we're tracking climate, we have direct evidence, which explicitly indicates that global warming is occurring based on actual changes in global temperature. So our average temperature for the year, as it changes, can indicate a change in global temperatures. We also have indirect evidence, which is evidence that seems to support the idea of climate change, but does not involve a direct measure of temperature. So like ocean levels rising, glaciers melting, a change in weather patterns, and the temperature of the ocean. So this is indirect evidence of actual atmospheric changes. So direct evidence using historical data is typically used from scientists and farmers because they've been recording weather and temperature for hundreds of years. So patterns emerge, and then they often use these to predict future weather, such as in the Farmer's Almanac. And this direct evidence is limited as to how far back written records goes, so it's limited to the last few hundred years in certain places, and in places where humans may have been farming for a lot longer, those records might go back farther, like in the Mediterranean areas. Indirect evidence is types of evidence that exist to support the idea of climate change, but we aren't actually measuring temperature. So we can look at tree ring analysis, ice core sampling, fossil records of insects, and pollen sampling from the bottom of lakes. Looking at tree rings, they reflect the changing seasons of cold and drought, warmth, and precipitation during the life of a tree. Trees typically grow more when it was warmer and wetter than when it was cold and or dry. So, by examining wood from trees of different ages from different time periods, we can determine a continuous record of relative climate changes going back thousands of years. So, a tree's age can be figured out by counting the light and dark rings. It's easier to see the dark rings, so typically those are the ones that will be counted. To help figure out what climate a tree grew in, the scientists look at each ring's thickness, so how wide it is. Was the environment good or bad for that tree? So, in years that the amount of rain and temperature were good, a tree's rings were wider. If a tree starts to become thinner on one side than the other, it means the tree is going to be leaning to one side. And there's also marks and scars left by insects, disease, or forest fires. Scientists will often use a computer to measure the width of tree rings and to find other things they can't see just by looking at the tree. Ice core sampling is done by obtaining a column of ice 10,000 feet down on our ice sheets, so typically in the North and South Pole. And so we can be looking at ice that was made over 700,000 years ago, so way longer than there would be any written record of farming or temperature records. Now, by analyzing these tiny bubbles of air trapped in the ice, scientists can collect information about the quality of air at the time, carbon dioxide levels, and the approximate air temperature. We would also be able to see if there was a lot of volcanic eruptions one year due to chemicals that would be trapped in that ice. Lastly, we can look at fossil records and pollen samples. So fossil records and pollen samples from the past, we can determine what plants or insects existed at that point in the Earth's history. So plants and animals are adapted to particular climates, and so we can make conclusions about the conditions in the area where those fossils were found. So in Alberta, we're lucky to have a detailed fossil record for the Cambrian era, which was a period of rapid and great change in the diversity of life on Earth. And we have lots of aquatic fossils. So we can see that during the Cambrian period, Alberta would have been covered with water. So again, the Burgess Shale on Mount Wapta in Yoho National Park is known worldwide for its well-preserved fossils. So looking at climate change, we can take both direct and indirect evidence and go back hundreds of thousands of years to determine what our climate could have been then and what it is today.